Hello everyone. In this video, I am going to take an example of a discrete random variable probability distribution. So my concern would be to find an unknown because there is an unknown entry over here, and the major part of this discussion would be based on CDF. So we will learn how to find CDF for the discrete data and what is a graph, how we can write in terms of interval. So everything will be covered under this one, and then we will also include CDF for the calculation of probability if it is less than, greater than, or in between. So that is a one point, and the last two example dedicated means the last two part of this example dedicated to finding a unknown random variable if the probabilities are given in terms of less than equals to. So we here also we can use CDF. So let us begin with the first part. The part one is to find k. So when we want to find k, which is unknown in the probability distribution, so how it can be calculated, we will recall the properties. That first property says probability is always positive, or it can be zero but never negative. Second is when we add all the probabilities, it should be equals to 1. So we are going to first implement this probability equal to 1. So we will add all the probabilities from 1 to 7 given in this question, and after simplification we will get 10k square plus 9k minus this side is equals to 9k and equals to 1. When we are going to write it in all the terms on the same side, so we'll get a quadratic equation in k. And to solve a quadratic equation in k, we have two techniques. One is we can use the formula b square minus 4ac, and the second one is we can use the splitting middle terms. I will use the splitting middle term where one is 10 and another one is minus, so we can split the middle term, this one, right? And then we can club the two pairs and simplify it. So from the first pair I am getting 10k common and k plus 1 is here, minus 1 common, k plus 1 is here. So now we are ready with the two factor. One factor is k plus 1, the second factor, which is 10k minus, because here we don't have a number, it means it is a 1. And when you simplify, you will get k is equals to minus 1 as a 1 value, and 10k minus 1 is equals to 1, 0 means k is equals to 1 by 10. So we are going to pick this value. Reason being, this is not possible. It is making us PDF negative. So we got the value of k as a 1 by 10. So the first part is done. Now we are going to switch to finding a cumulative distribution function, and we'll see how we can write all factors and interval form as well as the plotting. So first step is we should plug in the value of k. So when we are going to plug in the value of k here, which is 1 by 10, and if we can convert it into decimal, that's also perfect. So I have converted into decimals because dividing by 10 is better in case of point 0.1, point 0.2. So all the PDF is now achieved. Next step is for the CDF. I am going to take three steps here. For the plotting also. The number one is we need to find out the value of CDF for these discrete values. So F1, F2, F3, F4, F5, F6 and F7. So for one, what you need to do is just write down the first entry as it is. Next, add the other one. You are going to get 3, then 0.3, zero point 0.5, and next is 0 0.8. You have to keep on adding the next value, right? And writing down 0.81. This is 0.83. That is a quicker way to get an answer. So when you add the last one, you are getting 1. So the moment you create a table form of the CDF, it means I know the till 1 the sum is 0.1, till 2 sum is 0.3, and so on. So till 1 all the probability will be added, so we are getting the answer. Why? Because probability of x means you have to take all the probability less than or equals to the x. That means these two number must be same. So with the help of table it can be easily calculated. Next is how to find this interval form. So let's pay attention. because when we say CDF, CDF should entertain all the real numbers. So here x can take any value between minus infinity to infinity. So that is a complete definition of a CDF. So if f can take any value between minus infinity to plus infinity, how we can write the function in interval form? So the step number one is look into your first random variable in the table, which is 1, and find out what is happening before 1, strictly less than. So strictly less than, there is no data, so no probability, so answer is 0. Next, from 1 to 2, and from 1 to 2, then 2 to 3, 3 to 4. So what is the process of writing? Because in the discrete data there is a jump in the value, so we have to make sure that one value should be entertained in the one interval, not as the same. So 1 is to be included in the lower value, 2 is not included in the upper value, it will come to the next. So in this manner we are going to jump. After 1 there is a jump because 2 is not entertained here, so jump of all the number is attained. And when you're writing all the means 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 is the last number, so x greater than equals to 7, what is happening? Now we have already added till 1 because there is no value between 1 and 2, so there is no probability added. It means from 1 till less than 2 the sum will be remain constant, and what is that constant? 0.1. And starting from 2, the moment you got a 2 your sum will be take 0.3, and it is same before 3 because there is no value between 2 to 3 and so on. So we always write in interval. So you just have to copy wherever you are writing equal to, you just copy the value. So after 0.3 I can copy this value, which is 0.5, and then it is 0.8. For 5 onward, less than 6, it is 0.81, and then it is 0.83. The last one is 1, because why we have written, because after 7 there is no data, so the sum will be constant as a 1 till infinity. So we got this interval way of writing a CDF. And then if we want to see how the graph look like, I have also plotted the graph of PDF. PDF is having a probability at a point, so it is a discrete values. But when we are writing a CDF, CDF means you have to cover whole real line. Like here you have a discrete entries. But when we say CDF, we have to cover whole real line. What is the probability behind any point on the real number? So what we used to do, we start from the first point number 1, and we are not including point 1 here, like this interval. So here this interval less than value 0, so you can see the strong bold line is given here 0, and the moment I take 1 there is a jump to point 1, and this is remain constant till 2. That means here I have taken a hollow circle. It means point 1 is not for 2. For 2 we jump to point 3, and it is constant till less than 3, and for 3 we jump to point 5. So this way we can get a step function. And last one is when it is a 7, the moment it is 7, 7 is not included in this interval, 7 is included here. And question is what is after 7? After 7 the value will be only 1, because we have to find probability of uh, x less than the number. So this is remain constant till infinity. So this is a graphical representation of a CDF. Now come to the next part. What is the next part here? We are going to target the third question, which is a third subpart of the question, where we have three probability based question. And right now I am interested not using a probability, using a CDF. So let us once again recall that what is the definition of CDF? CDF we write for this purpose whenever there is a equal to sign and less than, it means we can replace it by F, capital F. Now since we are going to implement for the problem solving, so we need to remember these three information in terms of a CDF. Whenever it is written less than or equals to A, we can write on F of A. And whenever somebody is interested to find probability of x strictly greater than A, So it is nothing but you delete f of a from 1, so we will get a strictly greater than. And what happened for in between? So for the in between, you have to remember, because there are so many other options. Equal to can be on the left hand side, there must be no equal to on both hand side. So there are other three options. But what you need to remember for the discrete, especially for the discrete data, we can write f of b minus f of a only and only if the equal to sign is in the upper side but there is no equal to sign in the lower side, then only we can write it. So we have to fix it. So we have, if we want to use CDF, every time we have to convert our question into this model, and then we can proceed with the problem. So let us see how we can implement it. The first one is very straightforward because it is less than as well as equal to, something like here this kind of thing. So we are going to replace this f of 5, and here you can see this is a CDF already in the table. So what we can see, we look for the 5 and plug in the value directly as a 0.81, right? The next one is greater than. So for greater than, we can just write down 1 minus of f of 5. So we have already calculated above 1 minus 8.81. So what is 0.81? So we are getting 0.19. Right, so we got the answer. Now the last one is to be taken care very carefully, that if I want to solve my question, because CDFs are already available with me, and I want to find out this question using CDF, not probability. So what can be done? The point number one is that there is an issue with the upper limit. Upper limit should be equal to. So whenever you are doing a discrete, this discrete has a different strategy as compared to the continuous. So in a discrete, for example, if you want to convert this strictly less than equals to strictly less than equals to 1, so what to do in that case? So for that, what you can do, the lower value is as per the requirement but the upper value is not as per the requirement. I need an equal to, so it means you do not have to include 5, you have to include 4. So what we can do, we can rewrite it that this is same as for the discrete data equal to 4, and then we can find out. Now it is okay, I can take a f of 4 and delete f of 1 from here, and 4 here is this one which is 0.8, and we have to delete f of 1. F of 1 is 0.1 and my answer is 0.7. So we can solve it in that way. Probability is also one technique, but right now my concern is how we can find the same thing using CDF. Why? Because sometimes, let's say if question is demanding you that using CDF calculate, then you are only bound to calculate this way. So we have covered. Next is where we have given with some probability, and we are interested to find out what is this C, and that to the smallest. So what is the technique here? We have already taken a less than value, that means we have already taken f of x less than or equals to x. This is same as the problem f of a. That means I can write down f of c should be more than 1 by 2. 1 by 2 I can write down 0.5. So f of c should be more than 0.5 for what value of c? So I can see from here the sum less than is, so this is not included, less than greater than 0.5, so this is also not, it is equal to 0.5. I'm looking for, these are the values. It means what I'm saying, I'm saying f of 4 is equals to 0.8, which is more than 0.5. I know that f of 5 is also 0.81, which is more than zero point 0.5. F of 6, which is 0.83, which is also more than zero point 0.5. F of 7, which is 1, it is also more than zero point 0.5. So we have more than one entries, like we have a 4 here, we have a 5 here, 6, 7, but we need to calculate the smallest. So the smallest one is here, c equals to 4. So we got a c equals to 4. Now in the same manner, we have a one more question. It is demanding that what is c, that f of c must be strictly less than 0.1 by 2 means 0.5. So we are interested to find out what is C when it is less than 0.5. So the same strategy I can implement for the next one. So I know that here let us see the situation. Here less than zero point 0.5 is yes, this is eligible, and this is eligible, this is not eligible, and afterward no one is eligible. Means you are saying f of 1, which is equals to 0 0.1, yes, it is strictly less than 0 0.5. F of 2, which is equals to 0 0.3, it is strictly less than 0 0.5. And after that we don't have, because if I say f of 3, which is equals to zero point 0.5, which is not strictly less than zero point 0.5, it is equal to zero point 0.5. So we look for strictly, it means only these two values are eligible. So we have to find the largest. So largest C is equals to 2, means largest value. So I hope this discussion has given you an idea how to implement CDF for the calculation of all such kind of problem. Thank you for watching.